Good morning, everyone. My name is Professor Patsie Polly, and I'm from the Digital and Immersive Education Research Group within the Department of Pathology, School of Biomedical Sciences at the University of New South Wales, Sydney, Australia. And this presentation really focuses on student understanding of muscle wasting in cancer cachexia using immersive learning approaches. This project was really a focus of Manisha, our PhD student's research project, which really wanted to evaluate the virtual learning environment in the classroom at university. So let's start why the focus on virtual learning environments or VLEs, and why is this important? Indeed, there was a heightened interest on virtual learning environments since the pandemic. However, we also needed to understand the idea of more control over learning and how we wanted to improve learner motivation. Indeed, also, how we effectively communicate key concepts when we're teaching difficult processes like cancer cachexia. The immersive and interactive experience for the learner also has to be considered when introducing these new methods of teaching and learning at university. When we started this process, we also realised that there was limited research focused on learning outcomes for students, improvement in student performance, and student motivation associated with virtual learning environments in medical science education. So let's take you through the types and varieties of VLEs that exist and the examples. For example, in Blackboard, which is a type of learner management system, we have the opportunity to use a system called H5P. And this is exactly what we did initially in our third year courses. We designed a whole lot of lab modules and lab learning to support students using simulations and, of course, building interesting content that really tried to unpack and explain the concept of cancer cachexia. You can imagine for an undergraduate student entering third year, understanding the topic of muscle wasting and how that occurs due to cancer is quite complex. We also looked at different ways of using immersive environments. So we use a 360-degree immersive system by taking photographs of our research labs and presenting them to our students in an immersive digital aspect to allow them to feel like they were actually in a cancer cachexia research lab. We used Immersive Editor and we also used Matterport to design some of these immersive lab environments. There's also other things that can be used as part of virtual reality experiences. For example, cave environments, also augmented reality experiences on iPads. We can also use different virtual reality with mounted headsets. So providing students with the opportunity to learn complex disease concepts while giving them the impression or the feeling that they're inside a research lab is very useful in undergraduate coursework. So when you look at all these types of environments, we go from a lower immersion over to a very high immersion type of learning environment. And of course, the idea of headsets has been very popular recently in higher education and actually in all sorts of training, skills and development. However, there are limitations with this as well, especially to do with cost and delivery of a type of product that would suit all types of learners. So there's higher immersion, improved engagement, improved learner motivation, and enhanced learning experience. But we needed to consider what our students needed to learn the sorts of concepts that we were talking about in our pathology course, Molecular Basis of Disease, which is the third year course in pathology offered to medical science students. So we opted to really compare and contrast the methods that used H5P and also 360-degree virtual learning environments. So let's look at some of these learning environments. On the top image there, we have an image of the 360-degree view of the Museum of Human Disease, which is a simulated environment of the real Museum of Human Disease that we often use to introduce our students to the way we present various POTS and various diseases that we think about in our coursework. Down below, you see the environment that Manisha produced with a 360-degree camera where she was able to uh, record various scenes within a laboratory and create a real live space for students to learn within. So the interesting thing about these environments, they provide a panoramic view of a real or simulated setting. Now, this is also important not only for students, but also for patients who would like to learn more about their disease state, and also carers who would like to learn more and can't always access information or learn information that is just over their head at the time because they're absolutely overwhelmed with the enormity of having cancer and cancer cachexia. So users can explore and interact with their surroundings, and we can create immersive learning experiences that potentially enhance traditional teaching methods. These environments are usually created using 360-degree cameras, and I mentioned that earlier. Manisha was able to take one of these cameras provided to us by colleagues in the Immersive Digital team here at the University of New South Wales and start to photograph various scenes within the lab. The environments can actually be accessed using desktops, smartphones, or virtual reality headsets, which I have overviewed already. So the research aims of this story really were to compare and analyse existing online lessons and platforms and conditions that apply online immersive virtual learning environments and analyse student learning experience and performance. We wanted to critically analyse the impact of newly created virtual learning environments and tools on student engagement and confidence. And we wanted to critically analyse and evaluate the impact of virtual learning environments and supporting online tools for student motivation and the impact they had actually on student motivation. So our method of evaluating these ideas, setting up and evaluating these ideas, was to rebuild existing online laboratory lessons for deployment into medical science courses. So we had a lot of simulations that we had built in former times, detailing how cancer cachexia comes about in patients suffering from cancer. We also had simulations showing how we bring mouse models to the student to understand how we work on the molecular basis of various diseases in our study, molecular basis of cancer cachexia. So we decided as part of this project to rebuild and re-innovate some of these lessons that we already had as simulations. So the first experiment and the third experiment actually are what we were going to build up and use in our third year pathology course where we taught cancer cachexia to third year undergraduate students. So the sizes in terms of the student numbers were 95 in 2022 and 83 in 2023. And the difference we wanted to see, we wanted to evaluate whether students had an improved learning experience when comparing H5P with 360-degree immersive environments, and later on in 2023, whether we could see the H5P versus the Unity environment. So we started our thinking by creating a method. We had a randomized group study, compared the study with 2 types of virtual learning environments within each cohort. We had quantitative data collection by Qualtrics feedback surveys and qualitative data collection by knowledge transfer tests. These were pre and post tests actually when evaluating student understanding of cancer cachexia. And we also needed to recruit our participants. Naturally, we had ethics approval, human ethics approval for all this, in order to collect knowledge transfer test outcomes, feedback surveys, participant observations. And the data analysis we used was a type of thematic analysis, content analysis, knowledge transfer quiz score comparison, and feedback surveys, as well as participant observations and focus group interviews. So when I'm outlining experiment 1 here, it really is, I want you to think about H5P versus 360-degree immersive environment. So the comparison of those two. We brought the students into the concept of learning about cancer cachexia. We had 2 types of experiments that we brought across as part of the analysis of cancer cachexia, qPCR, and electrophoretic mobility shift assay experiments. We used H5P modules with 360-degree photography. The content remained the same for both environments, and we had identical multiple choice questions which were used before and after. In other words, pre and post after the module. So these were our knowledge transfer tests. So if I'm to give you a little tour of our immersive editor, let's start this recording right now. Here's a view of the lab. So students proceed to various points in the lab and they're running their experiments by using various types of equipment. And they're able to click on various points, for example, PCR, and learn about what PCR is. Come back to a point in the lab, go into various spaces that use machines where the PCR reactions are loaded. We've used Unity simulations to do the pipetting behind the actual PCR experiment. So you can see students were able to walk through this environment similar to what we would experience in a real lab setting. So when we compared and contrast feedback survey responses from our students, when we were trying to see whether they were preferring H5P versus 360-degree lessons, it was clear to us that the H5P lesson seemed to be the overall interest for students in the way they were learning about cancer cachexia. So this was different to what we expected. We actually expected students to prefer the 360-degree format. So students often reported, I was engaged with the content presented to me within the module and 360 environment. Okay, so very interesting outcome here. So these were the data in 2022. So we asked the students, what did you like best about the H5P 360 module? Liked being able to do some of the lab experiments online. The questions provided suitable source for active recall. I like the mix of diagrams and text used throughout to explain concepts, lots of good multiple choice questions. What did you like least about the 360 module? It took way too long to complete. Learn more face-to-face, inability to practice techniques. The paragraphs of information are too lengthy. So while we try and give students as much as we can to learn a difficult disease setting, it was still something that it was a little bit overwhelming for them in terms of the amount of information that was provided. So that was experiment 1. And when we moved to experiment 3 in 2023, we were able to work with the Unity platform to see if we could assess changes or improvements in student learning. So this is taking us through the Unity environment, once again welcoming students into the PCR lab so they can learn about various aspects of lab learning. There's feedback given along the way. So as they enter this environment, they get briefed on the types of tasks they're meant to be doing. For example, setting up a PCR plate to compare and contrast control versus muscle specimens from C26 mice who've had cachexia. They keep walking through the lab, doing the similar things that we would do when we enter real lab environments. Okay. So when we looked at the outcomes for experiment 3, when we again evaluated understanding of cachexia, confidence, motivation, and engagement, we saw that students were still interested in doing these H5P and Unity lessons, but were more in favour of the H5P lesson itself, especially when it came to cancer cachexia modules for preparation and revision of practical or theoretical concepts. So this was insightful for us. Again, when we looked at the sort of information that students were telling us about, what did they like most about the Unity simulation? It was engaging, immersive, enjoyable, interesting, but again, students found what they liked least about the simulation: tedious, sensitive, too technical. There were issues. So the study outcome all up showed that students reported being immersed in both the 360 and 3D Unity environments. The quantitative data revealed an increase in performance with knowledge transfer tests, but the level of improvement between each group was not significantly different. There was no significant difference in understanding, engagement, and motivation for all environments. Okay, so while there was a perception that both environments were working quite well, students did have a preference for H5P lessons, especially for revision purposes. So our next steps in this study is really to reduce the cognitive overload provided by some of these types of environments. So while they may be very engaging in many ways, they can also provide too much stimulus, too much overload for the student. So the redesign of the 3D simulation is also something we'd like to consider. More instruction, less distraction, for example, and improve our student response rate, because students at times did not respond to some of these surveys, so we're wondering if we've got a full comprehensive picture. Before I get to the acknowledgements, I'd also like to point out that this is an opportunity also not only for teaching undergraduate students in medical science and medical degrees about complex paraneoplastic syndromes like cancer cachexia, but it's also, as I mentioned earlier, an opportunity to provide small, very engaging modules for patients and their carers to get their heads around an understanding of what cancer cachexia means, especially in the context of muscle wasting and fatigability. So with that, I'd like to acknowledge my colleagues, my PhD student Manisha Harirajan, who's just submitted her thesis, and her co-supervisor and colleague, Associate Professor Kristen Herbert. There are many other colleagues at the University of New South Wales and also abroad in Germany that we worked with as part of getting this study off the ground and developing all of these wonderful media that we were able to bring to our students. I thank you very much for your attention. All the best.